Hello everyone. In this video, we discuss about our tool called VReqST. It is a requirement specification tool to elicit and specify requirements for building virtual reality software products. This work was carried out at Software Engineering Research Center, IIIT Hyderabad. Building virtual reality software products is a cumbersome task. It involves too many stakeholders. VReqST will ease the overall requirement specification process. It has 5 steps. Scene, article, action response, behavior, and timeline are the steps. As shown in figure, a VR requirement analyst captures requirements from the customer. The requirement analyst is required to populate the model template for scene, article, action response, behavior, and timeline. These model template files are validated against respective validator files, which contain underlying logic to publish the specifications. In the end, the overall published specifications can be shared with VR designer or VR developer to build VR scenes with higher precision. Let's look at the demo now. Follow the documentation to create an account in VReqST. Access project section and choose desired model template validator to start authoring your specifications for a VR scene. Created projects will be listed under My Projects. The overall project section presents the projects managed by you and others who use the same VReqST instance. You can also view validators created by you and others in one place. VReqST allows you to create your own validator by appending the bare minimum validator that comes default with the tool. Choose Add Validator section and create your validator by providing a custom name. Choose Private to hide your validator from other requirement analysts who use the same VReqST instance. Validator Wizard allows you to add your own validation rules for model template files. These are the rule set conditions that validates the files for respective feature specification. Use default button to load the bare minimum validator that comes default with the tool. You can make necessary changes to these default validator files and publish them in the tool. You can update validators for scene, articles, actions, and timeline individually or all together and save them in the file so that you can reuse it for respective model specification. Now that we created a project and validator, we shall begin authoring the specifications for a VR scene. In this video, we use a soccer VR game specification to illustrate the features of the tool across all stages. We use a pre-authored specification to ease the demonstration. If we observe, we have a specification pane that loads scene model template in JSON format. Upon clicking the validated button, the model template is validated against the validator. Incorrect specification throws error as shown here and allows the requirement analyst to correct it until the validation runs into success. Scene model template expects scene dimensions and properties of a VR scene. The article model template expects the list of objects that are to be included in the VR scene. In our example, in the second stage, articles like ball, scorecard, stadium stand, goal post, soccer pitch, pitch markings, players, goalkeeper are defined. The requirement analysts are allowed to include new articles by choosing new button. They can edit the existing article by choosing created article and alter the specification. By choosing next button, all the defined objects are published under article model template. The requirement analysts are allowed to create as many articles as possible without any limit. Once the specification is validated, the requirement analyst is required to click on next button to move to action response step. In this step, the interactions between the articles defined in step 2 are to be determined. As illustrated here on screen, the action responses between game ball goalpost, game ball pitch marking, game ball goalkeeper, game ball scorecard are defined here. Action responses are typically defined between source object and target object, with response being synchronous and asynchronous. The action response model template also includes the state information of a particular object. This helps the VR designer or developer to define the states of the articles based on their action response over each other. The next step allows us to define the behavior of the action responses across the VR scene using conditional logic. The behavior step contains three modes: author mode, view mode, and publish mode. As illustrated on the screen, the left pane consists of code constructs and the right pane consists of action responses along with the articles defined in step 2 and step 3. The middle pane allows us to drag and drop the code constructs and the articles or action responses to author customized conditional logic to define behaviors. Here, for example, we illustrate goal point behavior, goal save, out of bound behavior. We can validate the behavior logic, flush the logic and rewrite or save it. This will list the saved behavior under view mode. We can author as many behaviors as required without any limit. However, we have an option to choose desired behaviors in a specific order under publish mode. This will help us curate as many behaviors as possible and choose only the desired ones for VR designers or VR developers to implement them in the VR scene. Upon publishing the behaviors, we are now required to define the timeline of all events in the overall VR scene. Most of the timeline events are trigger-based synchronous actions, non-trigger-based synchronous actions, trigger-based asynchronous actions, and non-trigger-based asynchronous actions. We need to place all of these action responses from the behavior step in a given timeline so that the VR scene animates accordingly. The timeline step, which is the last step, allows us to implement the timeline of all the events. Upon saving, all specifications including scene, articles, action response, behaviors and timeline are now published for VR designers or VR developers to consume. These specifications can be sent to design generation tools, code generation tools to automatically generate mock VR scenes with higher precision. This brings us to the end of our demo. Thank you.